In MCQ 13, this is a question with regards to periodicity, and we want to find out which of these sulfate salts actually, when dissolved in water, give rise to a rather acidic solution. So for the case here of finding out which is acidic, it always has to come back down to acknowledging that the metal cation in each of the solution here, each possess their own respective charge density. And charge density is actually proportional towards the cationic charge of the cation itself, or inversely proportionate to the cationic radius of the cation. And with a high charge density, this allowed the cation itself to actually polarize water. And from the polarization of water, they will actually extract a proton. So in short, it's fair to say that the charge density of a metal cation, if it's high, this will result in a greater amount of proton that's extracted, or a much higher proton concentration. And since pH is equals to negative log concentration of a proton, it's then fair to say that the higher the concentration of the proton, this leads to a much lower pH. So for each of the option A, B, C, and D, let's consider the cation over here. For A, we're looking at aluminum 3+, for B, copper 2+, C would have been magnesium 2+, and for D would have been a sodium+. So on the first parameter of cationic charge, aluminum is going at a +3, copper +2, magnesium +2, and sodium +1. So based off the cationic charge, you would have seen that aluminum is having the highest cationic charge, which could have been the highest charge density. But short of making a very premature judgment, let's take a look at the cationic radius for each of them, which can be obtained from the data booklet. So for the case of aluminum, we're looking at a cationic radius of 0.050. For copper 2+, we're looking at a value of 0.073. For magnesium 2+, we're looking at the value of 0.065. And lastly, for sodium plus, the sodium cation, we're looking for the radius of 0.095. And again, aluminum seems to be the most compact cationic radius. And again, if cationic radius is inversely proportionate to charge density, and that cationic charge is proportional to charge density, I'll say that aluminum ends up to be the one that has the highest charge density here. And with that, it will extract the most amount of proton from water, resulting in a very acidic solution. So the answer for this question here is A.